That's good if you want to train pilots, which isn't our mission. Our mission is research, and so our simulations you see don't move.
Okay.
There's no motion cue. The graphics are budget. To be
like Atari, kind of. Yeah.
I try to be
not that bad.
I wrote them, so you know.
So what do you write?
We must be humble.
What are you writing about?
These?
Yeah.
C, C++.
Really?
Yeah, written to raw OpenGL. Yeah. Runs on Macs, PCs, Solaris, Linux.
Okay.
That kind of went nuts.
So do you just run it on multiple systems just to test it out on multiple things?
No.
Or it just happen to be what's here?
It's because I want to be able to service my customers.
Okay.
Some of my customers are on PCs, or some are on Macs, and some are running on Linux. Very few are running on Solaris.
Right.
But in here, oddly enough, you still see a lot of Solaris still in use.
Is that just legacy?
The Sims themselves are running on Solaris hardware, and it caused us no end of trouble today.
I bet.
Crashed 2 or 3 times in the middle of everything.
So your goal here is to run tests on what could happen, if different things, different scenarios. How does that impact the hardware?
Sorta. What happens is that researchers get an idea. Let's research this, putting wings on backwards, making the tail bigger or smaller. What happens if we have some battle damage? Okay, and can we still control that? Yes. And so they build mathematical models that describe that. We stuff them into the sim, and they try flying it. Usually all software at their desk. As they get more needy, we bring them down into the bigger labs where they can hook up to hardware that can connect to actual aircraft systems.
See how it might actually do it.
Right.
So when the engineers and the mathematicians and stuff, when they put together and they say, we want to do this, how do they get it to you? What format do they get? Or do they just say, we want to do this?
Management has sort of a council, a research council. Here are a bunch of proposals. Which one, which ones do we think we can get funded? So let's do a good dog and pony show. Do some good pictures.
My husband was a DoD researcher.
There you go. You know most of the process already. It's much like how DARPA will do it.
Right, exactly.
Right? So a few pie-in-the-sky things. Let's get some funding. If they get first stage funding, we may not actually see much of them.
Okay.
Second stage, first stage funding is papers.
Kind of,
yeah, here's the math. We think it'll work. We probably won't kill anybody. Unless it's the DoD, they probably do want to kill them. Make kill, Maybe, we don't know.
That's why he left.
Yeah, well, people ask us, can we shoot the guns? No, we took the guns out. Big space, holds a lot of weight. We put experiments in there.
Exactly.
Yeah. We make the cement truck fly. The guys down the road will put guns on it, turn it into a weapon. Nice division of labor there. So, or sometimes I just say, we're the civilian agency. We don't officially kill people.
Not on purpose anyhow.
Yeah. So it's around about the second stage. They will probably get up to full-up sims, and now the budget is considerably higher because you're paying multiple people to work on something. The time in the labs, sometimes hardware that has to be purchased. Around about the third stage or fourth stage, we're talking actual airplane and the opportunity to fly. But in each one of them, there's a full review. Did we like what we saw up to here? Do we think this will be useful? Should we go forward with it?
So at the second level, I assume, are there programmers involved? I'm actually really curious on the software piece of it. So
the sim
you get some mathematician or physicist or engineer that says, well, why don't we try this, right?
Most of those guys are still coding in Fortran. The coders we have.
That was the very first computer programming class I took a long time ago.
Yeah. Actually, a few bits of the F-18 sim that was flying here today is still in Fortran.
It's not broke. Don't think so.
It does the job. And in fact, the reference sim we get from the Navy to compare it to. Oh yeah.
Well, I've heard China Lake's got a lot of Fortran.
Yeah. But this stuff has been working for 40 years. Why change? Still does the job. So, the sim itself is mostly C++.
Okay, that's a piece you've worked on.
I've contributed small bits to it. My piece is the graphics thing that's projecting in front of you, which started out as a pure research tool. All they wanted was the HUD, because we pay the best pilots in the world, to fly things that shouldn't fly, and somehow make it work. Right. So we don't actually need any of that for the pilot's benefit, but the researchers benefit because they want to stand outside the airplane and look at the rudder or the elevators. Or do we have flutter?
The mechanics of it.
Right. And Some of our models actually simulate pieces of the airplane coming off the flight, so that we can, you know...
Will it still go?
Yes.
Will it not crash?
Yes. And so they have bits and pieces that support that. But we're not here to be a competitor for, say, Google. That's not the goal. The goal is show the airplane all the bits, make it run on everybody's desktop. So if I've got a customer on Linux, I want that stuff running on Linux.
So do you export it to them if they're somewhere else? Like, is McDonnell Douglas even alive anymore, or did Boeing buy them? I used to know somebody that was a McDonnell Douglas engineer like 30 years ago.
Oh, yeah. This is very cool. Yeah. Insanity. Really cool.
I give them a lot of credit.
I wonder if they'll do that for you.